Hello everyone and welcome back. So starting in this video, we will begin looking at the Vertex cache system with a focus on the Vertex class. So Lee, we've heard about this Vertex cache quite a bit. Different radio shows, various other VTMs from the MMO class. Talk about it once again before we get started on it. Why do we need a Vertex cache?
Efficiency.
Efficiency, okay.
It all boils down to efficiency. The way to look at it is no matter how we get the information, we still need to get the information for our terrain. Whether we use a persistent system, such as the data storage system that we devised, we'd have to go and get the Vertex information from a file on a hard drive, which takes, an amount of time. Granted, it's not a whole lot of time, but it still takes time. And when you were talking about doing this for thousands, tens of thousands, hundreds of thousands of vertices, that amounts to a lot of time. Right now, we use the train generator in real time, which means we have to go get the height information from the train generator, and we have to do all that fractal noise calculation, all of the blending information, and all the other calculations that we do to generate our terrain in real time. And we do that for every vertex every single time a patch needs that information. So what's a way that we can reduce that? Well, using caching is how we're going to reduce it. What I mean by caching is we're going to make a couple of classes that is going to store the information. One is literally storing the information. That's the Vertex class. That's all it does, is it stores information about a single vertex. The Vertex cache is a class whose job is to manage a whole bunch of vertice information and make it easy for us to grab that information, retrieve it, and if that cache does not happen to have that information on hand at that point in time, it needs to do whatever it needs to do to go get that information, and then it holds it in memory for a period of time. Now, the duration that it holds can be, dealt with in a couple of different ways. We can say, hold it forever. That's also going to be fairly inefficient, because what's the point of holding Vertex information for a patch that's 1,000 miles away and it's going to take you 3 hours to get to it? So there's no point in keeping that in memory. You're just going to waste resources. So what we can do is do a distance check. So, and we're already doing that with the train manager. It says, hey, hold these patches in memory for this amount of time. And once you've gotten so far away from it, we don't need it. Delete it. So we're going to remove the vertices that are associated with that patch along with the patch, because we've exceeded our hold range. So we're no longer going to hold on any information. We're going to get rid of it. Another method that we're going to use is going to be pretty much like a time to live, TTL. Basically, if for some reason this information is still in the cache, for some reason our removal of a patch didn't catch it, that information's still going to be in the cache, and we're going to have a sweeper method that's going to come by, look at the TTL, and remove that information. Likewise, we're really not removing the cache information right the moment we say, hey, remove it. We're flagging it for removal. This is going to be the first time that we're going to be looking at using multi-threading in this train system. Before we were going to use it for patch creation, but I've removed that. But I will be using threading in the Vertex cache. What it's going to do is it's going to run the sweeper or the purge functionality in a worker thread, and it's going to come along every so often, and it's going to look for all the vertices that are flagged to be destroyed, and it's going to remove those. And we can also set up the time to live, the TTL, so that it can look at the vertices and go, this vertex hasn't been touched in so long that it's exceeded the TTL, and we're going to remove it. So that'll come by and help keep our Vertex cache from eating up all of the memory that we've got. So this will basically, what it boils down is the cache is going to try to efficiently manage Vertex data so that we don't have to create it either from the train generator or read it in from a hard drive unless we absolutely have to.
Okay.
So that's what the Vertex cache does.
Very cool. Well, do you want to just call that an intro, and then in the next video do the Vertex class?
I can. I think it's going to take us a good 15-20 minutes to roll through just the Vertex class.
Okay, very cool. Let's do that then, just to keep things in smaller, bite-sized chunks if we can. So that's going to wrap up an overview of the system. Thanks a lot.